What's up, guys? I hope you all are doing well. Welcome back to my YouTube channel and welcome back to another YouTube video. So, in this video, we will be looking at part 5 of our tutorial series, Scientific and Numeric Computing in Python. So, if you've been following along, guys, you'll realize that in the previous tutorial, or the previous video rather, we looked at the reshape method as well as the end method. So this lesson as well is going to be a hands-on experience. There's more methods that I want to introduce you to, and just all of the possibilities that can be achieved, with Python, and especially the NumPy package. So let's get to it. In this video, we're going to start off discussing a new concept. It's known as record arrays. Record arrays, however you want to say it. But the idea is that, so you'll understand, right? Let's just talk a bit of logic here first. You understand what a list is, you know what an array is. Now, an array contains elements that belong to the same data type, whereas a list does not. Elements can belong to different data types. Now, given the fact we are working with NumPy arrays, does that mean that every one of our NumPy arrays are going to be restricted to only containing elements that belong to the same data type? The answer is no. Utilizing record arrays allows us to create NumPy arrays that can have elements that belong to different data types. I told you, remember, think of an array as a table. We have rows, we have columns. So ask yourself, in the real world, in a table, do we only have one data type in that table? The answer is no. And this is why record arrays are here, right? They are here to allow us to have versatility. We have the ability to store different data types of information in different columns in our NumPy array. So it's super interesting. It's not difficult at all, okay? I will give you a simple example first. It's one that I sourced from the NumPy documentation. So have a look at this and, we'll take it from there. So we also understand that I introduced you guys to the fact that NumPy provides us with so many different types of data types, right? Variations of the ones that already exist in Python, right? Int 16, or int 64, int 32, and so on. Now keep that in mind, because we are going to be utilizing those data types. Those data types are what will be matched or mapped to the columns, the data type to which we want the column to belong to. So let's view an example, right? I'm creating a record array, recr, so that's the name of the object itself. Now within this numpy.zeros, I am providing a dtype parameter. So I need to provide in a tuple all of the data types of the respective columns. So assume I'm just going to demonstrate with 3 columns, right? So I'm going to be providing here within a tuple in the form of a string, comma separated, the data types. So I have I4, F4, A10. Now guys, I just want to explain something quickly, right? To avoid confusion as we build up on this. So this that you are seeing, the DType. So DType is the parameter, the values that you see, right? I4, F4, and A10. These are built-in data types that are provided by NumPy. Okay, you can actually Google a list of all the data types that are provided, and you'll be shown a list, and you can select and play around with those data types. Now that's the first thing I wanted to mention. So let's build up on this now. To add, so the values that I want to add to my record array, which is recr, is in the form of a list, and each row has its values enclosed in a tuple. I am providing I. I is basically integer, F is float, A denotes a string. The number you see after depicts or denotes the number of characters maximum that the string can contain. Okay, so really, now that I think of it, this is like similar to the way in which SQL works, right? You have these reserved data types for your columns, but it is interesting, right? So anyway, I'm providing. Remember, I assume I have three columns. One is an integer, the second is a float, and the third is a string. So I'm providing values now. I'm giving in 1. Let's just say I'm giving 2.0, as well as a string not more than 10 characters long. Hello. So that's fine. Now that was row 1. I'm having a second row, and the reason why I'm having a second row is because as you guys can see, I created a NumPy zeros array. It's having 2 rows and 1 column, so that's fine. I am having this to add now to it, which is basically my array of values that contain different data types. Okay, so it will make sense eventually, guys, if you are a bit confused at the moment. So 3.0, and we can say hello world, so that's fine. Now I have a standard array. I've got the values I want to add to my rec array, right? I've created a rec array up here. How do I know this is a rec array? It's because each column in this array is given a different data type for its elements. So let's go ahead, and now what we are doing is a simple slicing operation. Okay, so this is why you have to be familiar with basic list and array operations in Python before proceeding to NumPy and SciPy. So as you guys can tell, this will basically set all rows of the rec R to be equal to add, and add was our array that's 2 by 1. Okay, so let's go ahead, and what I want to do now is print this out for you so you can view what our rec R actually looks like. So I hit Control Enter, and I forgot to import my NumPy package, so I will go do that now. Import NumPy as np, and now I hit Control Enter. As you guys can see, right, it is interesting. This is a tabular form having 2 rows and 1 column. If I do a print recr.shape, and remember, recr is a NumPy array because the base form from which recr was created was NumPy.zeros, and then we did a manual operation to insert elements, at the indices, and that gave rise to what we see here, right? That bit of information there. Now, as you can see, the shape is still maintained 2 by 0. So that is interesting stuff. It's just that in this particular array, 1 row is a tuple of values, okay, instead of an individual element itself. So I'd like to speak now to you a bit about just a few important stuff. I mentioned the first thing was the data types. Feel free to Google that, a list of Python DTypes, NumPy. So I'd like to mention, right, the DType is an optional argument. If you saw when we were creating our, so I'll just do a numpy.zeros, and look here, guys. DType is set to float, right? Because by default, NumPy actually assumes that we are just going to create an array containing zeros. Basically, it's a standard array, NumPy array. It's not a record array in which the columns are having different values. If we want to have a record array in which the columns of the array support different data types, we'll utilize the dtype parameter name, and we'll provide our data types in the form of a tuple, in the form of a string, comma separating the data type for each respective column in the array. Okay, so one thing I'd like to mention to you now, right, is that you see I4. Let's look at I4. Now, the number you see in I4 and F4, because those are numerical data types. I4 is basically an integer. I stands for integer. The 4 we see is telling us the number of um, bytes. There are 8 bits in one byte, so that's why I4 is basically telling us that we're dealing with a number that has 4 bytes, and therefore it's 32 bits. Okay, and F4 is the same, 4 bytes, telling us that 4 times 8 is 32. Therefore, this is the same as float 32, right? 8 times 4 is 32. So basically, F4 is telling us float 32. A10, this is easy. That's basically A denotes a string. Right, that's the kind of like the value that denotes a string data type, and the number we see after tells us how long the string can be. Okay, so in our case, we just set it to a string of 10 characters. So I hope that makes sense to you. Now, that's really, if you got this, guys, then really that's the most important concept of record arrays, okay, in NumPy, in Python. So I'd like to basically give you another example. Let's just experiment with this new concept that we learned. So you'll understand, right? We just looked at an example, and you'll agree with me. Yes, we have a record array, but I'm pretty sure that you've been asking yourself, the way in which we added values to this array was not entirely, the most feasible, especially for a programmer, right? We are meant to do things the convenient way, okay? The comfortable way. So there are other ways to populate a record array instead of first, defining the values you have and then setting the record array to equal to those values. So let's experiment with another, technique of giving values or elements to our columns. Now let's proceed to do that. For this, I will create another recArr object, which is a record array. I will have a NumPy zeros. Let's assume we are working with the same as before. So an array that's just 2 by 1. Next, I'm specifying my DType equals 2. So what I will do for this is utilize the same representation as our previous example. So I want you guys to get the full understanding of the difference or different ways in which we can proceed to populate a record array. It's exactly the same as before. You guys can copy and paste it. Okay. Now, let's insert values into this array. So simple things, it's very similar to working with an actual table. So I'm doing call1 is equals to numpy.arange plus 1. Call2 is equals to numpy.arange 2. DType equals numpy.float 32. Okay, because we have specified here in column 2, we are working with a float that's 8 you know 4 bytes, which is basically 32 bits. So float 32, and we have in column 3 hello world. Now this is us having defined clearly. So logically speaking, the procedure is kind of the same, but the representation, right, and the manner in which we do things is different. So I've defined the values that's going to be placed into call 1, 2, and 3 as per my record array. I'm now proceeding to have a to add is equals to. This is a powerful method in Python. Zip. It's built into Python. Okay. Now zip is basically, as you can see here, guys, a zip object that yields tuples. Basically, think of it such way: a zip requires us to pass sequences or iterables that have the same length, in other words, same number of elements, and zip will basically collectively handle them in tuples. It will arrange them in tuples as per their respective position in the sequences or iterables that you provide. So I hope that makes sense to you. Now, within this zip, we are passing in call1, call2, and call3, the objects that are storing the values for us. Okay guys, so now that we have set up our zip function will be creating our rows of values, okay, for the record array. Now, by default, now basically what the zip function outputs, or the result of the zip function, is an iterable, and we have the ability to iterate or cycle through the elements inside this iterable or this sequence. So what we are doing is a simple for loop. Now I will set up a counter. We'll say j is equals to 0. Then for I in to add record array of j is equals to I, and we'll say j plus equals to 1. It's a simple 4-line for loop, guys. So this is our counter, the for loop itself. We are iterating through the rows, which are basically tuples in the to add sequence, and we are setting the index position inside the record array starting from 0 equal to that tuple of information, and we do cycle through. So we have a counter variable set up here. So what I want to do now is I want to print a record array, and now when I hit enter, you guys will see that this is the second way in which we can, if we want to, utilize to insert values into record arrays. So control enter, and as you guys can see, I have my array, and let's verify shape. So recr.shape, and as you guys can see, it's a 2x1 array. Now, there is one more cool feature that record arrays actually support, and I'd like to show that to you. So you understand, right, that at the moment, by default, the column names that we have for this record array is basically float. So it's basically in the form of this, right? F0, F1, F2, so on, right? That's the default representation that NumPy gives to the columns for a record array. It's the name of the column, okay? That's why we say NumPy is having arrays that can be compared to tables, because of a fact that NumPy, when working with the record arrays that are designed to provide tabular functionality, it gives its own default names to each column in the respective order. It's basically F0, F1, F2, and so on. Now we have the ability to actually change the names of the columns. So I will show you how to do that immediately. If you guys were wondering, right, how do I know the names of the columns? So as you can see, I go rec array, or basically record array dot dtype dot names. The data type of the column is the name of the column, and by default NumPy just gives everything in F. So F0, 1, 2, and so on. Now let me add that line of code here. Print recr.dtype.names. So that's what we see there. So I will create another cell. Okay guys, so what we do to change the names of the columns is as follows. We'll basically use a recr.dtype.names is equals to, and we are passing the names of the columns we have, or desire rather, and we pass it in the form of a tuple, comma separated, and the name of the column must appear in strings. So integers, floats, and strings, right? Because we have three columns that we are working with. The first one is an integer, the second one is a float, and the third one is a string. So that's that. Now print recr.dtype.names. I will comment the initial one out, and here you guys can see the new names of our columns in the record array. Now, one more super cool feature that I'd like to show you. So in a table, when we work with a table, oftentimes we'd like to receive or view, a specific column. Okay, what we will do is print the name of the array, and to get the column that you'd like to receive, all you have to do is next to the name of the array in a square brackets, right, a pair of square brackets, in string form, provide the name of the column that you would like to receive or retrieve. So I will comment these two out, and here we have it, recr integers, and as you can see, so if I do recr strings, and as you can see, there are two, hello world. So that is cool. And guys, with that, I think we will end the video here. We've covered quite a bit of interesting concepts in this video. I hope you guys found it interesting. I find it super interesting, and I look forward to, creating more tutorials and exploring more of these interesting concepts with you. So with that, guys, thanks for watching. Thanks for staying till the end of the video. Do make sure to leave a like, share this video if you found it useful, subscribe to my channel. Good luck with your work, and I'll see you in the next YouTube video.